Hello and welcome to DeveloperWeek Global Enterprise 2021. It is my pleasure to introduce your next speaker. This is Mr. Yochai Shaya. He's the Director of Solutions Engineering at Granulate. He'll now be joining on screen. Thank you.
Thank you, Marcus, and a pleasure to have you all here with us. As mentioned, my name is Bar from Granulate. I'm leading the global solution engineering teams here at Granulate. I will be speaking with you on how you can leverage improved application performance in order to enjoy compute cost reduction, where our core premise of Granulate would be that operating systems, both Linux and Windows, were designed pretty much as a generic purpose solution that aim to serve users behind keyboard in mind, which means that they are optimizing in order to achieve interactivity and fairness. On the contrary to that, modern production workloads will be repetitive. They will run with repetitive methods and will do the same thing over and over again throughout the day, where all they will be care about will be better performance, might be latency, throughput, simply CPU utilization, but of course, not so much of interactivity and fairness. So today I will explain how Granulate is helping organizations to improve their performance and as a result, also to reduce their compute cost. Covering a bit the cloud computing area, we can see mainly 4 points that help to the tremendous growth in cloud computing usage these days. First, we can see that the cloud computing helped organizations to have that scalability in their development cycles, where these days you would have the ability to deploy different changes, different hotfixes and features to production, while not being bound to hardware on-premise bare metal servers, which helps a lot to the product market fit of different organizations, allowing them to increase their user base and as a result, their margins and their revenues, due to the fact they have the ability to immediately deploy any changes due to the fact they are using cloud computing and not on-premise bare metal machines. Another point would be that different cloud vendors are providing with organizations flexible cost models. So I guess many of you are aware of the fact that there will be many ways of actually consuming cloud computing resources. There are different ways to actually being paid for them. So there are on-demand services, there are spot services, where each one will give you the ability to mitigate your cost on the cloud while actually enjoying all of the other benefits that cloud will allow these days. Third thing would be that cloud computing is providing with increased availability and data processing capabilities for different organizations. So it seems like these days everyone wants, for example, an autonomous car. One of the major reasons for why we didn't have an autonomous car before is due to the fact that to actually build an autonomous car that would be able to react and process for different data points at the road, you would need to process huge amount of data. Where the main challenge was to actually having the compute systems that will allow you to process huge chunk of data in an appropriate processing time that will allow you to build the relevant models on top of that, that will eventually be the guidance for these autonomous cars. I'm not speaking on all of the AI and machine learning algorithms that we are seeing these days, where almost every other company will now use. And it is, of course, required with many compute resources, again, in order to process these in an appropriate time. The fourth thing would be the fact that cloud computing is improving efficiency while enabling focus on growth for different companies. So before we would have the cloud computing or the cloud companies in general, there was a trade-off that we were needed to manage between our growth, whether it is in product features, whether it is in customer base, and the cost of our infrastructure, where both of them were quite bound in terms of that mentioned trade-off. These days, due to the fact we are using elastic cloud computing environments, we are, of course, and that's what we're seeing with many organizations, we are focusing our resources mainly on the R&D side, on the product, on the development, and on the research side, in order to have that improved solutions, improved products, and to be competitive with all the others competitors every company have. It means that when you are a small startup, you have the ability to penetrate a market quite fast due to the fact you don't need to spend a lot of resources, whether it is people, time, or technology, on the infrastructure that will allow you that. Problem starts when you are scaling, increasing your cloud compute cost without stopping for a second and actually mitigating that cost compared to the actual usage you have, which is what we are currently seeing as a major catalyst to the fact that now different organizations are searching for ways to reduce their compute cost. So they prefer that growth at the beginning, but now they have a huge cloud bill that they need to mitigate without, of course, compromising their business or their growth. Here we have a few examples of that immense growth that we are seeing in cloud computing usage. I guess that it's no secret for any of you guys here on the call that we are seeing for all of the cloud vendors a huge increase in usage, whether it is from small organizations and up to large enterprises, where everyone is currently seeking for ways to mitigate that increase in cost, searching for different solutions of different capabilities. When speaking about what would be the barriers of actually controlling your cloud computing cost, I would say that there are four main challenges. The first one would be that this is, of course, having a lot of technical complexity. So these days you will have different services, different applications. You would probably manage them on more than one managed service, or if it is actually self-managed, then you will probably have different deployments, might be Kubernetes, simple containers, big data workloads, where everyone will need their specific tweaks or their specific features in order to get control on your increasing compute cost. Which leads me to the second point, which is that doing and putting that effort in mitigating these compute costs depending on the relevant service will be completely outside of the company core business. So you would always want to keep competitive with the different competitors you will have. You won't need, or you don't need to reduce your compute cost or to put your focus on reducing compute cost, as it will, of course, will be outside of your core business until it actually have a huge effect on margins, on revenues, and then it will be kind of an emergency area where you will put many efforts. You will jeopardize performance, SLAs, in order to mitigate that cloud compute cost. The fact that we are having dynamic environments, whether it is big data workloads, simple API request-based services, storages that we need, multiple applications will do multiple stuff, and we will change them in a very repetitive manner. So these days we are deploying more changes, more features, more product enhancements to products, to solutions, to services that we have over the cloud, which means that for every new change that we will have, we will need to adjust the relevant infrastructure, whether it is simple VMs, containers, or Kubernetes, to the new needs coming from our deployed services. Point 4 would be the fact that there is shared responsibility when it comes to mitigating cloud compute cost. Different organizations will have the infrastructure team. It might be called infrastructure, cloud team, DevOps team, or SRE. In any case, where we would have the team that is in charge on the infrastructure, we will have the team which is in charge sometimes on research, which is a huge part of the application, and the team which is in charge on the actual development of the different applications. Where from one standpoint, the developer won't really care about what will be the cloud compute cost as long as he has his VM that he can work on in order to test his relevant changes, his relevant features. But on the other hand, the infrastructure manager, the DevOps manager, all he will be caring about is mitigating that compute cost, and that lack of synchronization between the two, it will leads us to that increase, that huge increase in the over provisioning rate that we are seeing these days. In one of the slides, I will speak on how Granulate exactly solving that issue without putting any additional overhead, whether it is on the infrastructure side, development side, or research side, and allows us to provide different organizations with a between 2 and up to 5x improved performance, whether it is latency, throughput, processing time, while actually reducing their compute utilization by 30 to 40%. When looking at all of these solutions, capabilities that organizations have these days in order to get control on their cloud spend, we can see the pattern as follows. At first, we will try to follow different best practices to enjoy that cost reduction. So we will start by cutting all of the overhead that we have within our infrastructure. We would probably manually search for over provisioning, stuff that can be reduced, stuff that can be eliminated, resources that can be saved in order to enjoy that cost reduction. Then we would probably start using an external tools. Most of them will be for cost visibility or cost monitoring, where these tools will provide you with all of the over provisioning that you probably missed. For example, Service X is now utilizing X amount of CPU cores, where it actually consumes over a monthly basis X minus 20, 30%. And there is an over provisioning to some extent. Then we would go for the automation, provisioning kind of solutions that will actually utilize that over provisioning to a cost reduction rate, again, to some extent, where of course, all of these are speaking many times only on an instance level. Most of them or some of them might be speaking on a cluster level, but when speaking on a service level solution that will allow you to almost autonomously reducing your compute cost, and it is additive to what you actually currently doing, we are speaking on more deep kind of method to actually reducing your compute cost. And we're seeing that now with many processors companies that now tries to actually build processor for specific use cases. So we are seeing companies trying to build processors which are tailored for streaming services, maybe for gaming services, or for big data workloads, whether they are machine learning or AI workloads, where all are trying to provide that additive value from a hardware perspective. So they are optimizing performance, which will allow organizations to reduce their compute cost by providing them with a better hardware with improved performance. Granulate would be a software-based solution that will allow the same optimizing applications performance in order to enjoy that reduction in latency, a reduction in CPU, might be an increase in throughput that will allow organizations to scale the number of instances, number of Kubernetes nodes that they currently need in order to support the same workloads they have these days. When speaking about a process of how Granulate would actually optimize performance and as a result will reduce compute cost, we'll start by stating that Granulate will be an agent-based solution. Granulate agent will be installed on service or services that your company would like to optimize, where a Granulate agent will be installed in a passive mode to start the learning phase. Within the learning phase of Granulate, it will recognize inefficiencies and bottlenecks that are happening on our operating system level, both on the kernel space and the user space, where it will optimize these in order to streamline our application. As a result, we will enjoy that improved performance. For an API request based off service, we will see reduction in latency, for example, might be an increase in throughput depending on the load balancing policy. For more of a big data workload, what we might see would be reduction in CPU utilization and reduction in processing time, job completion time. The goal of most of our customers would be to utilize these improvements for cost reduction. So by having that same cluster running with 20, 30, 40% reduced average CPU utilization, you would have the ability to either right-click terminate on 20, 30, 40% of your cloud instances, Or if you're having auto-scaling policies within these services, then that reduction provided by Granulate due to that improved OS level scheduling and prioritization will result in an immediate automatic cost reduction. So that would be the 4 stages of utilizing Granulate solution. When taking a deep dive into how Granulate exactly operates, so as discussed, Granulate will be an agent-based solution. That agent, once it is installed on service or services, it will be installed in a passive mode to start learning. During that learning phase, the agent will recognize inefficiencies and bottlenecks within the kernel and the runtime environments that can be optimized by better scheduling and prioritization. Once the agent will be activated, you would see that improved performance, reduction in latency, CPU, etc., etc. When looking under the hood of the agent, we can see that the agent is comprised with 2 modules. First one will be kernel module, second one will be a runtime module, where the process will be as follows. Once Granulate agent is installed on a machine, there's an auto discovery process. Within that process, the agent will recognize Linux flavor, Linux version, and kernel version. It will then load a relevant kernel module per these learned parameters using ins mode. Granulate kernel module will be loaded into the existing OS kernel and will optimize kernel space compute resources, mainly around the scheduler of the CPU. That same agent will also load a runtime module that will be per runtime environment. So, a JVM-based application will be loaded with a JVM-based module. A Python-based application will be loaded with a Python-based module, and a Go-based application will be loaded with a Go-based module, where you can see the different runtimes that Granulate support here on the customer environment side. In terms of operation, by the end of the day, Granulate kernel module will optimize on the kernel space, and Granulate runtime module will optimize anything that runtime manager masks from the kernel. With JVM-based applications, for example, it will be the JVM thread management, memory arenas that are being managed by the JVM. For Go-based applications, it will be Go routines instead of threads, and so on and so forth. Before I'm moving on, does anyone have a question? Okay. Moving forward, I will now explain a little bit more on Granulate gProfiler. In the meantime, if you have any questions, please let me know. Great, so I see we have about 6 minutes left. I will cover the gProfiler real quick. So when speaking about Granulate, of course, we cover the fact that Granulate will be an agent-based solution that by optimizing OS level scheduling and prioritization, it will allow you to enjoy improved performance and as a result, will reduce cost. Many customers of ours are asking us, what will be the process, what will be the patterns that the agent will learn within its learning time, and whether or not I can estimate what will be the potential gains when utilizing Granulate. For these reasons, we developed Granulate gProfiler. That's a completely open source tool, completely free, that any one of you can register, use, without having any engagement with Granulate. Well, for any of you who is not familiar with production profiling, I will provide a quick recap on what you guys are actually seeing here. So anything that you are seeing here will be a representation of an execution to the CPU and how much CPU time that same execution took out of the total 100%. So as we can see here, we are looking on a Kubernetes cluster where we have the kubelet process, for example, which we can see consumes at about 14% CPU usage. We have it in different applications that are running on our Kubernetes cluster. We can see a Python-based workload, Node.js-based workload, Golang-based workloads. where Granulate will utilize the gProfiler to provide prospects or existing customers with an estimation of improvement if you would like to actually POC Granulate agent-based solution. So by deploying the gProfiler, which is completely open source, completely free, we will be able to provide you with an estimation of improvement for each deployed Kubernetes cluster or VM-based service in terms of what would be the expected rate of improvement based on the kernel and the runtime overhead that we can see here on the gProfiler data. That would basically be the process of utilizing Granulate from profiling and up to actually optimizing your compute workloads, which will allow you to enjoy that cost reduction. Kind of summarizing what I just mentioned about the fact that currently we are seeing mainly two ways of optimizing compute workloads. Most of the companies will be focusing on having other processors, maybe improved processors, actually improving performance from a hardware perspective, not from a software perspective, where Granulate will do exactly the same, but from a software perspective. Well, of course, you can deploy Granulate on every Linux-based workload, regardless of the processor type, and it will be within the runtimes that Granulate support. On a general notion, it will be any JVM-based workload, Python, Node.js, Go, big data workloads, PHP, and Ruby. The few things that we do not support would be databases, .NET, in that case, and C-based workload. Anything which is not that would be able to enjoy that improved performance and, as a result, reduce cost. I wanted to leave a few minutes for questions, so please let me know if you have any. Okay, great. So you see there are no questions. In the minutes that we have left, I will go back to our presentation, showcasing for you one of our major case studies with Intel, where we worked with their autonomous car division called Mobileye. They have a huge PySpark workload that consumes data from different autonomous cars that are driving all over the world, aggregates the data over the cloud, and that PySpark workload will actually analyze it and provide actionable insights for Intel within the development of that autonomous cars. By deploying Granulate on that huge workload, Intel saw at about 45% reduction in job completion time due to the fact it is an ephemeral workload. 45% reduction in job completion time have resulted in almost full reflection in cost reduction, where Intel nailed at about 44.5% cost reduction on that specific workload. Not only that, it also allowed Intel to get that product to the market twice as fast, due to the fact their developers would have the ability to work on that same result from that PySpark ETL twice as fast as before Granulate. All of that POC were required from Intel with no R&D, no code changes, no configuration changes, and no maintenance were required throughout the entire process. Great. So with that in mind, I will leave it to it. I had a great pleasure speaking with you today. Feel free to reach out on LinkedIn to either me or any other representative of Granulate. If you want, feel free to access the gProfiler, deploy it, play with it a bit. Many of our customers are using it for their own benefit without having any commercial engagement with Granulate. So we would encourage you to do so. Thank you very much for having me.
Thank you, Bar, for a great talk here at Developer Week Global Enterprise 2021. Attendees, please navigate to the next available sessions on the tab to the left. Thank you.